I now want to have a look at, as I said rather flippantly, why I don't do domain-type research. It's one of these academic things that's coming of age, I guess, or it's one of these new things that's probably happened a long time ago, re-happening. And the buzzwords are students as co-producers and partners in designing courses and in research. Now, for reasons which will become sort of apparent in a little while, I've tripped over a problem with location-based services. The things that drive, inside smart devices, drive a lot of activity out there in social media and the Internet of Things and so on, and all sorts of activity going on based on certain assumptions about the accuracy of these. Now, I set the challenge last year for final year students, so they've had the third year undergraduates just about to graduate. And they do what's in your terms, I guess, is kind of a capstone terminology, but they spend about 9 months of their life spending about half of their time, third to a half of their time for the final year doing a project, a dissertation project. And I set a challenge, and 14 ultimately accepted it. About 12 from who are in the sort of September start cohort, and 3 or 4, I think it was, from the January starting cohort. These are the 7 students who contributed the data that I'm just going to show you a little bit about. They created something like 2,500 data points between these 7. The context is that GPS, the satellites that fly around the world that was set up by the US military originally for accurate tracking of where they were on the battlefields, and was then released to the public. They claim GPS gives you 95% of all fixes will be within 10 meters of where you actually are. An organization called Think Near publishes quarterly results about the accuracy that they can determine in location-based services advertising. 46% of reported locations are accurate to within 1,000 meters, which is kind of a bit different from this 95%, 10 meters. And they're showing something like 10% are in error by more than 60 miles, 100 kilometers. My students, though, who provide that data show something like 85% of their data that they've gathered using smartphones with taking photos is accurate to within about 25 meters. Now, the triggers to the research project, and which has actually had some interesting personal academic benefits, which I'll disclose at the end, was, first of all, is that the one? Oh, that was the thing that triggered me about September last year when I'd been down to a conference in Santiago in Chile, and I took 4 or 5 photos up about there. And I was a little bit surprised when I got back to the hotel and attached back into the internet and got the location services working and connecting to the photos and so on. And I found one that was 22 kilometers in error, or a few of them 22 kilometers, one about 11 kilometers. And I started thinking, this is kind of interesting. I wonder what's going on. Really need to do some research on this thing. I also then, noticed that I was standing still at that location. Okay, it's one of these big shed-like TK Maxx places, but there I was standing still, and the location services took me for about a 300-meter walk and back again, not quite at the speed of light, but pretty impressive. For a short period in time, my phone went for a walk at night time. Well, no, it didn't, but the location services did, and took me down to there. Well, this is a set of nights where I never go into that road at all. But for a couple of hours, it was reporting itself 450 meters from where I actually was or where it was. And then I took a set of photos, about 15 photos in a sequence in about 3 minutes, indoors, and it took it down there, and then to there, and then there. So those were last year, which kind of got me interested in doing this research. And then, as a matter of interest, I was at the top of Mont Royal in Montreal about a couple of months ago. And right on the top, right up by that radio tower, where your phone can see half the satellites going around the world in principle. It's got an infinite horizon almost. So it ought to be correct. Standing there on the Sunday afternoon, took the photo just out of interest, And that photo, 4,900 meters error. Got one student who lives out in Dubai, and he's been contributing, not into the set of data I'm going to show you briefly. He was at the top of the Burj Khalifa tower, the tallest building in the world just about. Again, you'd have thought that you might have got a good accuracy, but not as bad as there. But he was standing on the observation platform, and the phone was reporting itself 198 meters out over the 1,000-foot drop. What's going on? So those 7 students have contributed data and some insights. It turns out that different types of phone have quite different characteristics, and there are statistically significant differences. They're happening to, most of them are using SAS as it happens, because that's what we're using at the moment. So you can tell which procedure they're using. You can see the difference in the means, and so on. So Vishal Patel, different models. So for iPhone, you've got iPhones and Nexus, both quite different. Victor Horecny, who used actually SAS JMP, JUMP, because it happens to do rather cool things with it, the way he could use it within the Excel. 2 different versions of HTC smart devices. Indoors, enormously different accuracy level. Around about 10 meters position error there, whereas the Desire S, which is an early version, errors out at kind of about 110 meters discrepancy. So something's going on between the chipsets. So the students are coming up with these interesting insights, which I don't have time to do the work. We've got a teaching load and all those sort of things that we academics who are in teaching universities have. I'd never have time to find that out. Anyway, that's based on 200, 400 data points. So that's 400 data points there that Victor Horecny has extracted the location data, the EXIF data, and gone through that in some way or other. Farondeep Bains found something really cool. We knew that metal is kind of a bit of a problem, and in car parks you've got lots of metal. And you typically got cars in 2 rows, pairs of rows. So what he did, he went there into our car park where he could identify within half a meter where he was actually taking the photos, and standing in that gap between 4 cars, all nose to tail or whatever, at that height, and that height. He did it when the car park was full during the daytime, and then came back later on in the evening or on a Saturday, I don't know quite when there were no cars. Same spot. And as we can see, that's the one up here. That's 100 meters error. Down here, 400 meter error. Down there, under at bumper level, the level that all of those thrillers and car chase type films show us, you can put your little GPS tracker underneath the car. 935 meter error. Came back next day or whenever it was, same spot, there, 10-meter error. That's GPS accuracy. And a lot of these insights were coming because they were looking at the data they were getting and thinking, wow, I better get some more data. Or what happens over time? Does it vary? Well, Amna did only 14 locations, but she took readings every 1 or 2 minutes. And look at the changes from 80 meters to darn nearly totally accurate for 7 or 8 minutes, and then a huge spike again. And she's got a whole lot of those, and I'm just doing one from the top of Montreal, because having seen that 5-kilometer error, after the conference was finished, I went back up there, and for 15 minutes, 20 minutes it was, I think, I stood absolutely stationary, didn't move my phone, and took a photo every half minute for about 20 minutes. And I'm trying to get that data out to see what actually happens on a very accurately known location, on a very accurate timing. So I do a little bit. This is a visualization I did for SAS Global Forum of visualizing using SAS graphics to show how the phone varies in location during time at the same point and how it goes walkies. Or then this is a 2,600 points or 2,500 points spread around the UK. As a way of showing, this actually shows more about where the students collected their data, but the color coding shows the sort of errors in different places. And it shows that it doesn't matter where you are. The students' work, the students' research is helping me to say, it doesn't matter where you are, you've got all sorts of different errors at different places, and it doesn't matter really that much where you are. Big outliers. So, what I'm going to be doing now, this year, is actually get them to do it with some more focused questions. So they've done, for this last year, looked at different things, used really part of their literature reviews to kind of focus their own analytics. But then, from that, through these sort of insights, is now going to allow me to set much more focused research projects for them for next year, for the new cohort of students. So we could look at it in classic research terms. They've been doing exploratory research for a year, which has helped me to understand the next set of focused questions. What would be seriously cool, and this feeds into the IBM sort of side, and a colleague of Steve's, he's saying, if you want to use Watson Analytics, and I guess we're going to be seeing a bit about Watson Analytics tomorrow, aren't we, in the demonstration. There's a bit that's easy to get access to. And if you guys could all contribute through your students, get them to go out and collect, a couple of hundred photos, extract the EXIF data, pair that with the known location where they took the photos to within, the nearest meter or so, and pour the data back to me over the next 6 months. And if you could get all of your students to do that, and if you're interested, I'll give you a sort of spreadsheet design for recording the data on, then we could actually have something really, really interesting, pull the data through, and for next year, we could report how Watson Analytics can take 100,000 data points worth of locations data to characterize the inaccuracy and all the other things that Watson Analytics could do. And what I want to do in a sense for research would then be to do the same thing with that same kind of spreadsheet, known location, measured location, phone type, phone operating system, et cetera, whether Wi-Fi is on or not. The whole set of parameters we're beginning to discover are actually relevant. And extend that out to schools across the world as part of a cool project to enthuse students at almost all ages from, say, 12 or 13 upwards. A bit of interest on project design, how to identify where your true location is, the measured location, a little bit of trigonometry to do that distance calculation, and then feed it back, and then we can begin to develop a longitudinal research project that I'm, say, coordinating in principle, that works for quite a while, helps the industry to begin to understand the limitations of LBS in the way they want to use it for the business, identifies governance issues as well. Lots of interesting things we could use there to build research into much earlier stages of school than we've traditionally expected. Generate that enthusiasm for data, for analytics, understanding or developing the questions, finding those interesting answers, the things that why we're here, I hope. Oops. Come on. Has it died? Can you forward it on? This has stopped working. Can I have the next slide, please? There should be one more slide, at least. Okay, I'll talk a bit about it. What's actually been interesting, so I've been helping or having students who are kind of co-producers with me. They're collecting a lot of data. They're coming up with insights. I consolidated the data, coming up with further insights. And one of the things that has done has been to put me into the position as an academic, which is kind of interesting, that I am probably the lead academic worldwide reporting on the accuracy and inaccuracy of location services in these sort of devices, and am now an academic who goes to business level conferences run by Informa, who are the big worldwide company who provide a lot of conference services and publication. You've probably seen some of your academic books published by them because they own one of the big academic publishers. And I'm there with a governance perspective of this sort of thing, because people are assuming that you are where your phone says you are. You are within 100 meters of each other or 50 meters. And so it's building academic credibility, it's building reputation for the university. And so if you can find projects like that, where you can get students to capture much more data than they would usually do at an undergraduate level, and then if you've got 4 or 5, 6, 7, 8, 9 students doing that, you can do the consolidation. Yes, you will give them attribution in your papers. Those 7 were named as contributors in 2 or 3 papers I've published so far. 3 of them were co-authors of a paper at SAS Global Forum in April. So, how often do we get final year undergraduates co-authoring papers with us? How cool is it for them? One young gentleman here who presented here, not even as an undergraduate last year. He'll be talking to you straight after coffee. There are things we can do which break the mold. Get our students working with us, helping us. Helps us to develop our profile, our academic institution's profile. Think on that, ladies and gentlemen. And on that little note, I've got an idea. I'm not going to take questions just now on this one. I want to do something at the final session this afternoon. And to do that, I need to